Hello, everybody. My name is Mikhail Ananev, and I work for one of the biggest banks in Russia, Sberbank. And I would like to share with you some ideas about how to build data ecosystems using Clojure philosophy and bottom-up approach. My talk is inspired by Rich Hickey talks like language of the system and other, and I think that Clojure's ideas and philosophy has a great potential for building information processing and data processing systems at scale. I'm going to talk about data integration problems between different companies. And the first part of my talk, I will introduce the problem context of big companies. It's a boring part. Our company has several hundreds of systems, and each of them has tons of different data. Systems are integrated each other in some complex way. When you start to work under some business task, you will need to find right data. There are hundreds of systems, and a lot of questions arises. How to find right data in that landscape? What is the data quality in particular system? What is the security rules? How data is secured? What protocols are used? And so on. In order to get answers to that questions, you start to learn different sources of system requirements where systems details are described. In a big company, such knowledges are in a lot of tools. You may find information about schema in Confluence for one system, and the other system holds their schema description in the enterprise architect, and so on. And they might lack all of these tools that they intended for human-to-human communication. Machines cannot understand and directly interpret knowledges in such tools to perform some useful work. And there's always a gap between system requirements or schema description in that tools and the real code of that data in production. Another big problem is that we have a fast growth of the data sources and schema sources. We cannot stop this growth, and we should be effective somehow in such a rapidly changing world. When we process our data, we should accommodate many rules and policies. Law enforcement, business rules, bank regulatory compliance rules, all of them are present in the data governance process. How do we achieve all data governance goals in such complex IT landscape? Another story, there is no one runtime and no one common type system. We have many of them. And how to achieve data governance goals in such situation? How to achieve data quality requirements or meet security requirements when data travels from one runtime to another runtime? Another story. Okay, we have a lot of internal problems and hundreds of data sources. But one day your business buys another company and tells you, here is a new company. When we can work with data from systems of another company, when systems of another company will use data from our company, a lot of question arises. How to perform data mapping between different data models? How to perform knowledge exchange between programmers? What about data security when data travels from one company to another? And there is a ton of work for the years. And I like people, don't get me wrong. But when we need to integrate two systems to perform data exchange, then like those guys, we perform a lot of work by hand in a point-to-point manner. We find by hand system details in different tools described earlier. Only people can understand such details. Then we write integration requirements by hand for other people, and only people can understand and interpret such requirements. Then people write code for the data integration, other people perform different tests, and so on. But remember, we have talked about the growth of the data sources, data governance. This situation isn't scalable, so digitalization is impossible. Can we do something with that? I think we need to find a way to explain our knowledge to machines. And our knowledge should be in a human readable and machine readable form. Then machine can help us in a rapidly changing world to perform a lot of boring work in data integration processes. When you start to build data ecosystem between different organizations, at least you should solve two basic problems: digital identity and global metadata, and build global metadata system. In a digital identity system, people and machines from different organizations should be identified and authenticated. And then we need a system where different companies can describe and connect data in machine-readable form. In the next part, I would like to discuss about information and its properties and about object-oriented design. Little conventions for this talk: that information and data are interchangeable notions during my talk. In the many standards, you can find the different definition about information. There is a common part for that definitions that information is a fact or ideas or concepts within a certain context. What's great about information is that it is readable by humans and machines directly. Humans and machines can read and understand the idea of number 42 or idea of the word hello. And if we put such information on the wall, nothing changes. Machines still read it by using machine vision, and people can read it. Information is independent from containers or carrier, but information needs a context for interpretation. We don't know how to interpret a 42 without context. Is it a temperature or speed? But 42 as an idea exists without any context. So information itself exists without interpreter. Information is immutable values. You cannot change a number 42. If you add 1 to 42, you will get another number, 43. It is another value and it is another idea. If we drop a letter O in the word hello, you will get another idea, and hello is not changed. Information has great property of natural comparison. You can compare two values directly, and machines can do the same. Another great property of information is natural composability. Let's imagine we have a CSV file with that table, and every value of that table can be read by human and machines directly. And every value, like a brick in the wall, is immutable. We can build any data construction from little values using them like a bricks. And any data composition has the same properties of equality. Notice that there is no hierarchy in that data composition. Every value is independent, and we can set different contexts for interpretation by row or by column, and defined context is a separate thing from this data composition. And constant schema changes is objective reality. If our business has new business goals and we need to add another data like phone or postcode, we just add it without touching previous data composition, and we can build bigger data composition, and code for processing previous data composition will continue to work. So what about objects and their properties? We need to clarify it because in many companies domain models built upon object-oriented design. From the books about OO, we can find that objects are containers that holds data, state, and behavior. But for simplicity for our talk, let's define that objects are containers for data. If we read such definitions, we see that information and objects are different concepts. Here's the one. So it is a template which defines a structure for information that it can hold. What can we say about attributes like email or social security number when they are out of that objects? Are they out of definition domain? How to express them separately from that class? What about equality? Equality of containers and objects and information differs. But more important to say that now we can't read information directly. Containers are opaque structures. We need some means to deal with information inside containers as for human and for machine. We maybe define some code. And if our business domain changes, then we need to define new structure of the container and define new code to deal with this. Here's a typical story in enterprise when two teams need for data integration. One team say, here's our business domain entity, my person. Another team says that in their systems they have another similar business entity, your person. How to deal about common unified class structure? How to perform data mapping? How we can compose information from those two classes? And how many code needs to be written to operate on that data? There is a lot of stories that enterprise tries to build unified class model and forced to use it in every project. At the start, you have several hundreds of fine-grained classes. After several years, there may be several thousands of unified classes. And then your business buys another company. Here's the one. And we have another several thousands of good objects or classes. And how to perform data mapping or knowledge exchange in such situation. So a little summary of the part. Information and objects are orthogonal worlds and have different nature. And object composability is awful opposite to data. A knowledge description in OO style is always new dialect for human and machines. And if we occurs in situation where a group of organization needs to deal about unified data model, it is very, very hard way. So, data-driven approach for naming knowledges. The first big idea that gives us Clojure to solve that problems is naming things. From information definition, we learned that information needs a context. When you start to describe some notions, we need to define context for interpretation and exact meaning. Let's define notion of scoring. Is that scoring from risk management or from anti-fraud processes? Without right context, it is difficult to communicate. So let's define such context, and this context gives us more information about scoring. This scoring from anti-fraud story, but still not exact. But this description gives us more or less exact meaning. In a company Acme, there is some business process in anti-fraud and this scoring should be considered within an anti-fraud context. And so for different organizations, we can define separate context and describe the term scoring in a different context. It is like DNS in a digital world, but for the data. We can name our things in the following way. It's just idea, proposal. The first level we describe an organization name. Next level is about description of the main entities. For example, business processes, domain knowledges, and system data. So we can define unique data identifier without knowing a physical address. And of course, we have a good story for short names. It is aliases. We can write names for our notions from different business contexts and combine them together. And we can extract the meaning, exact meaning of what is the client, what is the contact, what is the address, and so on. So what we have, when two people from different organizations needs to talk about data integration, they can use global names to indicate which data need to be processed. And global names is a detailed coordinates in of data in digital universe. Global names gives us another good thing. We can name our systems, our data flows, and we can visualize them for the particular business case. And there is a clear picture that person data flows from CRM system to the data warehouse. Another good thing that we can get from global names is an enterprise search. If we use Lucene to index the names of different data from different systems, we can find a required data model much quicker than if we search it manually, for example, visiting different teams. So here's the example of such queries. So summary. Global names plays the great role for organization of data ecosystems. Global names are human-readable and machine-readable form of the coordinates of the data specification in the digital universe. Global names set interpretation, context, and exact meaning of the some business notions. And global names help us to organize enterprise search and visualize data flows and help people and machines to understand each other. Another great idea from the Clojure is an ability to specify data structures for different business models using data-driven approach. There is nothing new under the moon. We have a great example of data-driven approach to build worldwide dynamic system. It is an internet. Here is the data generated from server, and it travels via the wires. And here's the interpreter for information, browser, and which operates on data from stream. Instead of building unified model of classes, we can introduce digital alphabet, and every business can describe their data model using this alphabet, and everybody can read it, and human and machines. Here's the phrase, datum information. I can combine letters from this phrase and make new words, uniform and radio. And you can read it and understand it and compare it. So does the machines. And if I would use objects, then I can't cut half of object's information, this blue circle, and combine new object using its parts like uniform. So the main idea of the data-driven approach is description of information based on a small alphabet with some rules, and every business can write its own story for every domain, and everybody can read it, like book in a library for every possible knowledge domain. Here's the well-known idea from Clojure is connect data specification to global names, which belong to different organization and application domains. Here's the three parts: global names, predicate and machine and predicate for machine and text description for human. Here's an example of data-driven alphabet. It's almost like a Clojure spec, and nothing new for you is here. It's an example. And here's the specification and data examples which can easily read by humans and machines. So imagine there is a web application where you can define a global name for every notion specific to your business domain. Then you can describe a data specification using some small subset of spec and put some text description for a human. When you save it, you can easily it can be easily serialized to same data-driven format and sent through the wires to a different company. On the other side of the wires, it can be easily read and understood. Also, we can combine pieces of data specifications like letters and describe domain entities using digital alphabet and attach them to the data specification. Also, we can describe security rules and visualize our entity using some good interface written in reframe. Another good story that we can describe different piece of code that operates on our data and register that piece of code as data with global name. For example, a conformer2 is a code that converts our data from information model to some physical representation. And there is example of registration of code in some global metadata registry. Now, every programmer from different organizations can easily find our code and use it for data processing, or maybe for data quality and security. And Eden is a good example of information representation. In central part you can see on the left side is metadata with global names. On the right side is data itself. And this is example, sample of Eden can be converted to different physical representations by registered conformers. So if we have a machine-readable data specification, now we can easily generate domain entities from different organizations using global names as arguments. There is nothing new for you, and we can generate random data. But if we attach some dictionaries to our metadata systems and put generated samples via conformers, we can easily achieve a good data samples for physical representation. Here's an example of such operation. We can generate JSONs, API calls, or maybe we can fill SQL database. So the same idea works for about automatic data validation. If you have some domain entities in Kafka stream, you can validate them by spec using Apache Spark or Flink, and specification can be available via API. Here is an example of such automatic validation, and this approach can significantly reduce amount of work when you deal with information from different data sources. What's great about automatic validation is that machine can use spec to explain what's wrong with your data in big Kafka streams. So summary, data-driven approach is a good idea to build data ecosystem between organizations. Same principles as in internet. Open standards for digital alphabet and data specifications is required. Each organization may describe data model in terms of their business context in such way that machines and people from other organizations can read it. And machines should be used to generate sample data or validate data. Leave hard work for machines. So, possible dream process. Let's imagine we have such metadata system which is used among different organizations. On every step from business level to programming level, we can operate with metadata. Here's a possible high-level architecture of that metadata system where programs are first-class citizens. And the database may be based on blockchain technology. Every member of data ecosystem can read and write data specification without disclosure physical structure of their systems. And blockchain can, for example, safely propagate metadata between different members and in an immutable way. Every member of data ecosystem in parallel way can describe the integration boundaries of their systems. And there is no need to adjust data model to some uniform object model. Also, we can link particular attributes from one data model to another because it is not an opaque thing like objects. We can link directly attribute to attribute. Also, we can link different domain entities using data-driven approach and attach conformers which can secure our data or provide data quality or data transformation. So we can build easily data lineage and visualize data lineage when we build views from different sources. Here you can see which particular attributes came from. So metadata systems gives us that everybody lives in their local context without unified model. But when we need to start to integrate one system to another, we can make data mapping between different models without hassle of objects. When people sleep or have a rest, machines can operate under the readable knowledges and help people to reduce their work. And we can build semantic data web between different organizations. Data subscription from different sources becomes much easier. You need just put required names for data, what you need, and you don't need to know the physical addresses of that data. And you can combine sources from different systems. Also, we can achieve significant reduce of work in ETL process between data integrations if we have some unified information representation alphabet where we can do some data quality, security operations, and so on. So machines may significantly help us to work in the data ecosystems and achieve data governance goals. and Clojure ideas can be used to build such systems at scale. Thank you.
Okay, some questions to Mikhail. Just raise your hand, don't hesitate. Okay, I see the one.
So a classic question, like, do you plan to open source some of your solutions?
No, we just use Clojure ideas because enterprise have very specific requirements, security concerns. And if we build some financial data, metadata systems, we cannot use open source. There is no right solution for that task.
More questions?
Thank you. Did you read the book called Semantic Web?
Yes, a little bit.
It looks like you're reinventing semantic
yes.
web ideas with the Clojure, which is more of these ideas from semantic.
Yes. Yes.